Alright, let's get started with lipid transport as we review this figure from your book. Now this process gets kicked off after you eat something that has fat and cholesterol. These fats and cholesterols are converted to micelles, as you can see here. And these micelles are formed as the fats and cholesterols are acted on by bile salts. Now if you remember, these bile salts are created in the liver and stored and released by the gallbladder after a fatty meal. Now after these micelles form, they travel to the intestines, where a pancreatic lipase will act on them to form free fatty acids. And it's these free fatty acids that are going to be taken up by the intestinal enterocyte, where they will be reesterified into triglycerides that can be exported into the lymphatics as chylomicrons, as you can see here. Now this chylomicron will be taken to the systemic circulation, where it will be acted upon by HDL, which will transfer ApoC2 and ApoE to its surface. Now this step is extremely important, as when the chylomicron enters the circulation, it only has ApoB48 on its surface. Now ApoB48 is important as it mediates the secretion of chylomicrons into the lymphatics. But for chylomicrons to be taken up by the liver, or parts of the chylomicron to be incorporated into adipocytes, additional apoproteins are necessary. Now once HDL transfers ApoC2 and ApoE to the chylomicron, ApoC2 will activate lipoprotein lipase. Now lipoprotein lipase is found on the vascular endothelium of adipose as well as muscle tissue, and it catalyzes the same reaction as pancreatic lipase in the gut. Here, the lipoprotein lipase will degrade triglycerides found within the chylomicron into free fatty acids, and then it will incorporate these into the local cells. Now after this, the chylomicron becomes a chylomicron remnant, and this is taken up by liver hepatocytes via the ApoE receptor, as you can see here. Now after this, the hepatocyte will take triglycerides from the chylomicron and combine it with cholesterol to form VLDL, and this is then released into systemic circulation. Now after release, VLDL only has ApoB100 on its surface, and this brings us to an important point. If a lipid particle has ApoB100 on its surface, this means that it originated from the liver. This is in contrast to ApoB48, which if it is present, means that the lipid particle originated from the intestines. Now after VLDL enters systemic circulation, it is acted on by HDL. Here, HDL will transfer ApoC2 as well as ApoE to VLDL's surface. After this, ApoC2 will activate lipoprotein lipase on the vascular endothelium, as we just discussed earlier, and triglycerides found within the VLDL particle will be converted into free fatty acids and incorporated into the local adipocytes and muscle cells. After this process, the VLDL particle becomes an intermediate density lipoprotein, which then delivers its contents to the hepatocytes via the ApoE receptor. Once in the hepatocyte, the IDL particle will be acted on by hepatic lipase, which will further degrade the remaining triglycerides within the IDL particle to form an LDL particle. Now this LDL particle is then released back into systemic circulation, where it can be taken up by peripheral cells via LDL receptors. Alright, well that's going to wrap up lipid transport. See you in the next video.